And good afternoon, everyone. Welcome back to the Radical of Math. My name is Dwayne. And in this video, we're going to tackle question 4 of the free response questions off of the Advanced Placement Pre-Calculus exam of 2025. Now, full disclosure, this is being recorded before question 3 because question 3, best question of the 4 by a country mile. So, I'm going to put the link to the PDF, that way you can follow along. But for question 4, it is kind of a half and half mishmash of logarithmic functions, words are hard, and trigonometric functions. So, as prior to the other videos, organizing, figuring out which problem to attack, and how I would attack this as a student would be in the order C, A, B. C, A, B. So we're going to do that now. And this free response almost felt like a gimme. It almost felt like a gimme. I'm not going to lie. So let's start with question C. So you're given the function and it says find all endpoint values in the domain of M that yield an output value of 0. So once again, we have been asked a question of domain. The exponential function is an Algebra 2 concept. So we already know that for all values, the range cannot be negative. E to the x is always increasing. So let's go ahead and do some factoring. And now you see why looking at the problems are important, because this is free points. This should not challenge you. And so now what we have is we have e to the x equals 4, or e to the x equals negative 3. We can immediately toss that one out, because we know e to the x can never be negative in the range. And so we know that x is the natural log of 4. So I would say for question C, if I'm looking at it from a point value perspective, I would only give this question 2 points. On the 9-point scale, I think it's only a 2-point question. The first for the factoring, and the second recognizing what your allowed range is. All right, so let's go and do A. So A is a 2-parter. So part 1 says solve g of x is 4, and it gives the caveat it's in the domain of g. Okay. Logarithmic functions, also always increasing. So let's go ahead and divide. And then for x, by definition of log, is 3 squared, which equals 9. So the property that's your property. So keep that in mind. So Pretty straightforward question. The other one, a little bit more challenging, just a little bit. That is, h of x is 3 equals 4 cosine squared x, and the interval is 0 to pi halves. Now, don't do this on autopilot. Recognize you have a half closed interval. You can include 0, but you cannot include pi half radians. Don't autopilot this. Recognize what's going on. So we're just going to divide. Square everything. Now, at this point, you should know what this value is over the interval. Now, the problem is you're trying to do this under time pressure. So, trust but verify. Draw yourself a triangle. We know pi 3 over 2 is a special triangle. So I'm going to put it in degrees. We'll convert the radians. It'll make my point. And now cosine of this triangle, and it's in quadrant 1. Notice I've drew this in quadrant 1. So what this means is the adjacent over the hypotenuse. Because remember, SOHCAHTOA. And so you see adjacent over. So we know that x is 30 degrees, which is pi over 6 radians. So, question A, pretty straightforward. Question B will be the one that may trip you up. And so, question B1 says, write this expression as a single logarithm base 2 without negative exponents. Without negative exponents. So the first thing to understand, and now that I think about it, I didn't give you a point value. So on A, I would say that's another 2 points. This will be a 5-point question. Question B will be a 5-point question. So you want to simplify. So, the issue that you're going to have is this is a 2. I miswrote that, so let's go ahead and reset. This is the expression. And so the first thing we need to do is recognize that. We just put the 3 back in. This is 2 cubed, as mentioned. Then, these means you can multiply. That's a 2. So this, and that is the answer. Log 2 of the quantity 8x. So here, you just have to know, you need to know log AB is log A plus log B. You need to know that. And in the previous discussion about exponents and logs and how they're inverses. Lastly, trig problem. Let's do some trig. I like trig identities. I think they're great. Big fan of trig identities. So this question says, rewrite this. and has a caveat that says tangent x appears exactly once and there are no other trig functions involved. So, clearly, you have to manipulate this. So, this is a very rare Pythagorean identity. So here's the catch. So if you know this one, you can derive the other two. I'm going to divide everything by sine squared x. That's its cotangent. Cotangent x. So notice is that. But we know what that is. We know what this is. Let's go 6 tangent. And then we have a cotangent and a cotangent. And now the problem becomes very straightforward. These two cancel out to 1. And so you have 6 over cotangent x, which is 6 tangent x, which is the solution. So, my thoughts on question 4. So, as you saw and heard, I had a few little errors in this that I had to correct along the way. So this is a question where if you try to autopilot it, just like I did unintentionally, you're going to lose points. So my thoughts on question 4 is the first part is 60% of this is an Algebra 2 question, and then 40% was trig. I feel this question was designed to induce error. Because if you start getting numbers misplaced and all that, this becomes an easily missed question. You had to know the most obscure Pythagorean identity. So you got to have enough common sense to go, can I derive it? And if you can derive it, this becomes very easy. So, in terms of quality of question, I can only give this question a 4 out of 9. And the only reason why I'm not going with a lower score is because of the simple fact that question 2 was so easy, and this was just a little bit harder. So I will leave you with that. So in our next video, we're going to tackle what I think is the best question by far. And that is question 3. Make sure you like, follow, subscribe. Take care of yourselves. Take care of one another. God bless.